So the first question, this question here, you're supposed to prove that the left-hand side is equal to the right-hand side. Now, when you are proving, okay, always look at both sides of an equation and determine which side is the simplest. The one which is the simplest, that's the one you can easily simplify to get the other side. All right? So, he didn't do the homework, but he's not paying attention. Can you pay attention, please? I expect you to look there. Right? So here we are going to simplify the left-hand side until we get to what? The right-hand side. So the first thing we'll say, left-hand side is equal to, we rewrite the left-hand side. Okay? That's 2 to the power of 2x minus 1 plus 4 to the power of x plus 1. Okay? The objective, as I said, is to simplify the left-hand side until we get the right-hand side. Okay? So the next thing now, you can see that we have got this plus here. Yes?
When you say the left-hand side is the left side equal to the right
Yes,
side.
we don't have to write that. Don't have to. Okay?
So we can just put, we can just carry on the sum exactly like that.
Yes, don't worry. We are going to get the right-hand side. Don't worry. Now, when you get here, you must also use common sense. You see that on the right-hand side, we've got an exponent which is 2x. You see that? That 2x. It means here, I need to create that 2x, and here, I need to create this 2x. Let the question guide you. Okay? So, I'm going to split this up using the first law. Remember what I told you, that if a raised to the power of m times a raised to the power of n, just multiply those two, you get a to the power of m plus n. But in this case, we are going to move from the right-hand side towards the what? The left-hand side. Okay? So, here, I'll end up having 2 to the power of 2x times 2 to the power of 1. Okay? I've used the first law for this part. Right? Now, because there is a plus here, there is an addition sign, it means we need to factorize. Whenever you see a question under exponents where there is addition of exponential terms or subtraction of exponential terms, it means your knowledge of factorization is required. That's why I did factorization grade 9, grade 10. We don't teach factorization in this grade. Okay? You are expected to know how to factorize. So, plus. Then here, we have got that 4. Okay? 4 is the same as 2 to the power of 2. Okay? Before, I don't want to simplify it in my head, so I'm going to write it as 2 squared for now. Then raise to the power of x plus what? Plus 1. Okay, I don't want to complicate things for anyone. I'm going to do it step by step. Then, here, write as 2 to the power of 2x times 2 to the power of 1 plus. Then here we are going to remove the bracket. Okay? So this 2 multiplies the x, you get 2 to the power of 2x. The 2 multiplies the 1, you get plus 2. Yes?
So you just back to the top where it says left-hand side. And then the middle row where you took that 2x plus 1 and made it into 2. Isn't it supposed to be 2 to the power of minus 1?
Yes. Minus 1. Thank you for that. Go to minus 1. Thank you, so that you are following. Powerful with the minus 1 is negative. Okay, thank you. So let's carry on. Okay. So that you are following, that's supposed to be minus 1. Now, when you get here, we need to simplify this. Okay. So, next step will be say 2 to the power of 2x times 2 to the power of minus 1 plus 2 to the power of 2x times 2 to the power of 2. I have used, again here, I have used law what? Law 1 here. From that step to that step. Okay, I also use law 1 from here to there, moving from the right hand side of law 1 towards the left hand side. Okay, are you following? Huh? Then, when you get here now, you identify the common factor. I'm sure you can see that there is a bracket there, which means you need to take out the what? A common factor. Right? So we take out the common factor. Now our common factor is what?
2 to the power of 2x.
It's 2 to the power of 2x, which is what we have on the right hand side. Right? So this becomes 2 to the power of 2x, open bracket. Now once I take out the common factor, I'll be left with 2 to the power of minus what? Minus 1. Do you agree with me on that? So I'll end up having 2 to the power of minus 1 plus. If I take out the common factor, I'll be left with what? 2 squared. End up having 2 squared. And you close the bracket. Okay, and maybe someone is wondering, how is he going to get the 9 over 2? I'm almost there. Okay? Then move on to the 2 to the power of 2x, open bracket. 2 to the power of minus 1. If we use definition number 3, that is x to the power of minus n equals 1 over x to the n. Okay? This will give you a half plus that 2 squared is equal to 4. Following that, then we are almost there now. 2 to the power of 2x, a half plus 4 gives you 4 and a half. But 4 and a half is a mixed number. We can write it as an improper fraction. We get 2 to the power of 2x times 2 times 4 plus 1 gives you 9 over 2, which means the left-hand side. So we make a conclusion to say, therefore, the left-hand side is equal to the right-hand side. Then we are done. Okay, so this is how you do it. Yes.
So that's right, that's the reason you have to use it for this. Both like left-hand side.
Yeah, well, see, it's a conclusion. I have proved that the left-hand side is on the right. So at the end, you have to write a conclusion and say, therefore, the left-hand side is equal to the right-hand side. Yes.
So let's say the question says, show that you choose the left-hand side of it, but then you want to work out and it turns out not to be the left-hand side. And it turns out that they are not
Yes. But you see, the thing is, in most cases, when you're asked to show, you use the left-hand side of the right hand side. So you just have to show all the steps that either the left-hand side or the right-hand side is equal to the other side.
It's going to be a clear, more simple.
Yes, it will be as clear as possible in terms of the simplification. It won't be complex. Okay? So make sure you know how to do that. Right, so that's the first one. Let's move on to the next one. Do you have any questions before I move on? Are you following? Okay, let me carry on with the next question. Alright, the next question. Since we have a subtraction and an addition of exponential terms, it means your knowledge of factorization is required, your knowledge of the first law is required. Okay, with the first law, moving from the right hand side towards the left hand side. So you need to remember that a to the power of m times a to the power of n is equal to a to the power of m plus n. But in this case, we are moving from the right hand side towards the left hand side. Once you understand that, you won't have any major issues. Plus your knowledge of factorization. Okay? So, the numerator, I need to create a common factor in the numerator. In the denominator, I also need to create a common factor. So the first step would be to say 3 times 2 to the power of x, because the first term in the numerator is already simplified. Minus, by using law 1, moving from right to left, I'll get 2 to the power of x times 2 to the power of minus 1. All over. Okay, all over. Now the denominator, the first term is simplified as 2 to the power of x. The second term, I have to use law 1. Okay, so I have to write 2 to the power of x times 2 squared. Okay? Yes?
Let's say 1 mark.
Well, yeah, you might get 1 mark for that step. Okay, for applying law 1. But get 1 mark. Yes.
So what if you did, you know, when you do the double fraction thing, like double fraction as in and then
Why bring fractions in? Don't complicate it. The addition and subtraction of exponential terms, there are 2 key concepts that you need to be aware of. One, the use of law 1, moving from right to left. The second one, the creation of a common factor and factorizing. Right? Don't stress. Okay? So from here in the numerator, what's the common factor? 2 to the power of x, open bracket. The first term, if you divide it by the common factor, you get 3 minus. The second term, if you divide by the common factor, you get 2 to the power of minus 1. So we're going to come to your fractions. Okay? But after taking out the what? The common factor. We're going to come to the fractions. Then here, it will be 2 to the power of x, open bracket. Divide this term by the common factor, you get 1. Right? Plus, divide that whole term by the common factor, you get 2 squared. Usually, when you are doing questions like this, right, when you take out the common factor in both the numerator and the denominator will cancel out. Okay? So, these two are going to cancel out based on the second law of exponents. Okay? Once the x is eliminated, right, I'm going to simplify that. I'm going to write it. This becomes 3 minus 2 to the power of minus 1. Everyone, you must know that it's equal to a half. Okay? Then 1 plus 2 squared, that's a 5. Because 2 squared is a 4. Okay? Then the numerator, we've got a fraction, so 3 minus a half, that will give you 2 and a half. Okay? Now 2 and a half is the same as 5 over 2. Okay? Remember I did fractions, so I've written it as a mixed number. I'm going to convert it to an improper fraction. If I do that, I'll get 5 over 2 divided by. I'm converting this division line to a division sign. It's always better that way. Okay? I've converted the 2 and a half, 5 over 2. I've converted the division line to a division sign. Because I've got a fraction. That's why I'm doing that. So this is divided by 5. I can put that 1 there. Now, here, remember, you write as 5 over 2 times, you introduce multiplication over 1 over 5. So the final answer will be a half. Because this cancels with that. Final answer will be a half. Okay? Right? Any question? Yes? Okay. There is no other method to do a question like this. There is no other method. What is 3 minus a half? 2 and a half. Then, how do you convert a mixed number to an improper fraction? Denominator times whole number. 2 times 2 is what? 4 plus 1. Get what? 5. So 5 over 2. Then I converted the division line to a division sign.
It's just when you get that first one, you need to say 3 minus 1.
I understand. But don't complicate it. It's not difficult. Once you get here, you should come to your mind that, okay, I'm almost there.
Yeah.
Listen, I just want to give you a hint. When you are doing these questions, it's always better to work with improper fractions or proper fractions. Don't do your calculations using mixed numbers. Don't convert common fractions to decimals. You will complicate things. And remember, a question like this here, it will say without using a calculator. So you're not supposed to use a calculator here. You have to show all your working out, every step, how you will get to your answer. As a teacher, I would want to see how you end up getting a half. No decimals, no mixed numbers. Convert all mixed numbers to improper fractions. It's much better to work with improper fractions or proper fractions.
So then why did you use a fixed number there, sir?
Because 3 minus a half is what?
Okay, I understand how you got it, but then you say, no, you say don't use fixed numbers.
Okay, listen. I could have written it straight away as 5 over 2. But someone was going to end up asking, how did he get 5 over 2? Remember, I'm a teacher. Even if I was writing a test to I would do it this way. Okay? But at this moment, I am a teacher. I need to make sure that each and every one of you understands how I end up getting this 5 over 2. Where did I get it from here? I can write, if I'm writing a test, I can skip this step. I can. But you see, I'm a teacher. I need to make sure that everyone understands how I move from here to this 5 over 2. So we start with the simplification, mixed numbers. We did mixed numbers in the lower grade. Then improper fractions, we did that in the lower grade. When you're writing a test, if you want to skip this step here, it's fine. Just
the only thing is, like in the test, I will take the 3 minus half, and then I'll just put like 3 over 1, and then I'll just cancel the ones, and then I'll get like negative 3 over 2 in each one.
And now you are not supposed to do that. If you do it step by step, using your basic concepts of math, you will never go wrong. Okay. Now we move on to the next one.
Yes, sir.
Right. The next one is actually like the one that I just did. The concept is the same. The denominator is one exponential term. The numerator, there are 2 exponential terms there. So we have to use our knowledge of factorization and draw 1 in the numerator. Okay? So this will be equal to 2 times 3 to the power of x times 3 squared plus 3 to the power of x times 3 to the power of minus 3. All over. Okay? The denominator is already simplified, but I'm just going to use lower 1. 3 to the power of x times 3 to the power of negative 2. Like that. Please, don't ever make like a mistake of trying to cancel out terms when you like this. You have to factorize first. Okay? So in the numerator, what's the common factor? 3 to the power of x. Open bracket. If you divide the first term by 3 to the power of x, you'll be left with 2 times 3 squared plus 3 to the power of minus 3. All over. Now, in the denominator, I'm going to swap the position of the terms. Now, I'll start with 3 to the power of x. Okay, so I'll write here 3 to the power of x times 5 times 3 to the power of minus 2. Okay, you can do that because of multiplication. Okay, then these 2 terms are going to cancel out. 3 to the power of x and 3 to the power of x will cancel out. Then I just need to simplify now what's inside the bracket in the numerator. So 2 times 3 squared. Now 3 squared is 9. 9 times 2 gives me 18 plus 3 to the power of minus 3, that's 1 over 27. So that will be 1 over 27. Right? All over. All over. Now, from here, your knowledge of fractions is required. From here now, your knowledge of fractions is required. Then, the denominator is 5 times 3 to the power of minus 2. 3 to the power of minus 2 is the same as 1 over 9. Okay? So I can write the denominator as 5 over 9. Any question? You okay how I got this 5 over 9? Okay, you see 5 times 3 to the power of minus 2 is the same as 5 times 1 over 3 squared. And that will be 5 times 1 over 9, which gives you 5 over 9.
And 1 over 3.
So if you're going to all 5 over 1,
And then 3 to the power of minus 3, this is equal to 1 over 3 cubed. And that's equal to 1 over 27. Using definition number 3. Okay? Then, once you get here, no need to get confused. 18 is a whole number, plus 1 over 27. That will give you 18 and 1 over 27. Okay? All over 5 over 9. Now, if you look at it here, the denominator is a common fraction. The numerator is a mixed number, so I need to convert it to an improper fraction. Okay? Let me go to the next page. What is 27 times 18?
487.
4?
487.
487 plus 1. That will give you 4 what? 88 over 27. Now I'm going to
That's 1.
No, so 486 is 486 plus 1.
Okay, alright. So that's 487 over 27 divided by. Now I've converted the division line, this division line here, to a division sign. It's always better to do it that way. Okay? So I've converted that to a division sign. So this will be 5 over 9. Then we convert that division sign to what? Multiplication. Then we invert the fraction. So you get 487 over 27 times 9 over 5. Right? This 9 is a factor of 27. So we can get 487 over 15. Okay? Now, can that be simplified? No. Because, okay, 3, if I put 3 here, it cannot be simplified. So this will be the final answer. You can't simplify. There is no common factor between 487 and 15. Okay? So that will be your final answer. You following? Huh? Alright. Let's do the last one. Take the last one. Now, this one here, it requires the knowledge of prime factors and factorization for you to carry on, and a little bit of mathematical manipulation. Okay? So, the first step, we are going to convert all the bases that are not prime to prime. So this will be 3 squared, okay, all raised to the power of x minus 9, all over 3 to the power of x minus 3. Okay? Now, I want you to know that from now on, if you have a term like 3 squared, all raised to the power of x, you can swap the positions of the exponents. Okay? You can swap the what? The positions of the exponents. the reason why you have to do that is I need to create this 3 to the power of x. Because a question like this requires your knowledge of factorization. Okay? Now, when you're in grade 9 and grade 10, you did factorization. Probably you didn't understand why you need it, but you realize that factorizing is a concept that is applied in other mathematical topics. Yes?
So,
So, can you come again? Okay, if we swap these two, we'll get 3 to the power of x, and the 2 goes out, then it becomes 3 to the power of x all squared. Huh? That's the what? No. This is different now. We are using the law number 3. Go back to the table with the law. Don't confuse law number 3 and law 1. Okay, so this is the same as 3 to the power of x all squared. Okay? You can swap the exponents. Right? That technique is required in some questions like this. So, from there, I can write that as 3 to the power of x all squared. Right? Minus 9 all over 3 to the power of x minus 3. Okay? Now what I'm going to do, to make it a little bit easier for you, I'm going to introduce another letter, okay, which is not x, which is not y. I will just use k, okay? Generally, in this grade, when you do some questions that are complex, we use k, which is what is called the k method. So I'm going to use the k method here because if I try to factorize that as it is, a number of you are going to get confused. So I'm going to introduce another letter and say, let k be equal to 3 to the power of x. I just want to take you back to grade 9 and grade 10. So for me to do that, I'm going to introduce a new letter which I will call k is equivalent to 3 to the power of x. Once I do that, it's gonna make it easier for you to relate what you know from grade 9 and grade 10 with this question. So where there is 3 to the power of x, I'll put k there. Where there is 3 to the power of x here, I'll put k. Later, I'll come back to 3 to the power of x. Okay? So this becomes k squared minus 9 over k minus 3. Now in grade 9, what do we call the algebraic expression which is in the numerator? It's a difference of what? 2 squares. So your grade 9 teacher taught you how to factorize by using a difference of 2 squares. Last year you taught how to factorize by a difference of 2 squares. So this becomes k plus 3 times k minus 3 all over k minus 3. Okay? Don't forget the answer must be in terms of x. So in the end, I'm going to put the 3 to the power of x back. But the k method or the substitution method helps me to make it simpler because to factorize this when it's like this, it's a little bit more complex. Okay? So these two will cancel out because they are like terms. So you'll be left with k plus 3. But what is k? K is equal to 3 to the power of x. So I'll put back my 3 to the power of x. And then I'll do that. You're following? Right, so that's how you do it. So I have done quite a number of questions now, right, with regard to the key things on exponents. Now I need to move on to rational exponents, then exponential equations. The topic is quite long and it's very important. Right?